Alright, next example of completing the square to solve for quadratic equations. Right there. Now for this one, same thing. First step is to separate out a constant and a variable. So subtract the constant 3 to both sides. Left hand side is left with 8 times x squared minus 2x equal negative 3. Second step is to make sure the leading coefficient is positive 1. So convert positive 8 into positive 1 by dividing everything by positive 8. So I got x squared minus negative 2x over 8 is basically the same as minus 1 over 4 times x, and I'll leave some space in between, equal negative 3 over 8. Now the next step is, of course, again, we want to make sure that we add the value of b over 2 squared to both sides. So what is b over 2 squared? Well, our b is negative 1 over 4. So if we were to evaluate b over 2 squared, that will means same as negative 1 over 4, because don't forget the negative sign, all divided by 2 squared. But hey, a fraction divided by a number is the same as the numerator, negative 1 divided by the product of these two. So that means this is the same as negative 1 over 4 times 2 squared, which is, let's see, 4 times 2 is a negative 1 over 8 is negative 1 over 8 raised to the second is positive 1 over 64. So positive 1 over 64 is the thing that I want to add to both sides. Just include everything in the middle. Got x squared minus 1 over 4x. Right? Well, guess what? We have the quadratic expression on the left with the leading coefficient of the invisible positive 1. So same way of thinking, make a pair of empty parentheses. Look at the first term, x squared, and then the third term, and then the second coefficient. Multiplicative factors of x squared is positive x and positive x. Looking at the third term, I want to come up with two real numbers that multiply together to give me back positive 1 over 64, but also added together to give me back negative 1 over 4. Well, what if I try 1 over 8 times 1 over 8? That's, hey, that's positive 1 over 64. When I add these two, that is 2 over 8, which is 1 over 4. So common denominators, keep it. Add the numerators. 2 divided by 8 can be simplified out to 1 over 4. And yeah, I can come up with these two fractional factors on the top of my head, but because I already did the b over 2 right here, this turns out to be negative 1 over 8. That's why I was like, what if I try 1 over 8? Well, but 1 over 8 gives us positive 1 over 64, but not negative 1 over 4. So what if we convert these two into negative instead? So negative 1 over 8 times negative 1 over 8 is positive 1 over 64. But then if we take these two factors and we add them together, that's going to give us negative 2 over 8, which is negative 1 over 4. So hey, minus 1 over 8 goes here, and another 1 minus 8 goes here. So negative 1 over 8 and negative 1 over 8 are the two factors that goes into here. What about the right hand side? Well, let's see. For the right hand side, I got negative 3 over 8 plus 1 over 64 comparing the two denominators, the smaller denominator, 8, is actually one of the multiplicative factors of the larger one. So I can go ahead and convert the smaller one into the larger one, 64, by simply multiplying this by 8. So if I multiply the denominator by a number, I have to do the same thing for the numerator. So that means I'm going to have negative 24 over 64 plus 1 over 64. But hey, keeping the common denominator 64 and just adding the numerators, I got negative 23. Yeah, negative 23 over 64. So that's the right-hand side. Okay, now the next step, well, I got two identical binomial factors multiplying together. So that's the same as saying x minus 1 over 8 square equal to negative 23 over 64. And then, of course, I want to solve for x, so I had to get rid of the second exponential power and the minus 8. Well, I can take a square root of both sides. That's going to cancel out the exponential power too. So left-hand side is x minus 1 over 8 equal the right-hand side. Well, the right-hand side, I only have division under the radical. So by the loss of exponent, I get to put one radical for the numerator and another radical for the denominator. But hey, when we take a square root of something, that means we're going to have plus or minus. Okay, so square root of 64 is going to be plus or minus 8. So plus or minus and 8 right there. Now, square root of negative 23 is going to give us an imaginary solution, okay? Because we're not allowed to have any negative number underneath any even root. So with the negative 23, if we rewrite it a little bit, if we rewrite it into imaginary number, square root of negative 23 is the same as negative 1 times positive 23 with only multiplication, under the radical. I get to use a lot of exponent and just separate this common root into two distinct ones. One goes with the negative 1 and one goes with positive 23. Well, we know that square root of negative 1 is I, and since 23 is a perfect, not a perfectly prime number, it stays the same. So square root of negative 23 is equal to I times square root of 23. So that's what we're going to have on top. And then, of course, if we want to solve for x, just add 1 over 8 to both sides. So we're going to have positive square root of 23 over 8 times I plus 1 over 8. And then we're going to have x equals negative square root of 23 over 8 times I. And then plus 1 over 8. And you guys can go ahead and check to see if these two are really the imaginary solutions of this equation. But yeah, this is how we complete the square to solve for quadratic equations.